So my name is Lucas, obviously, and we are Castle. What are we about? We are about preventing account takeovers. Sounds simple, but a good question might be, what is an account takeover? So an account takeover is basically when a malicious actor takes over a legitimate user's account. This is almost always by guessing the password, often by stealing it from an existing password list that's been leaked. And usually at mass scale, when these things happen, there's always a sort of background level of compromises, but usually when this happens, it happens in a very obvious way, in a very intense way for a short period of time. It's also worth talking about what is not an account takeover. Like, we are not really focused on the scenario where a bad person comes along and signs up for a new account. That is more of a fraud scenario. We're really trying to protect the user from having their account compromised by a third party. We also don't really focus on the sort of legitimate user behaving badly scenarios when somebody tries to take advantage of your company's policies to game the system, or just simply violating like policies around account sharing or things like that. So our goals are really to permit legitimate access to the user while detecting and blocking malicious attempts to the same account. We want the user to be notified of this action when it happens, if their account has been compromised, and learn and improve our system so over time the false positive rate is minimal and only the bad actors identified and mitigated. So obviously part of the problem is trying to figure out who is good versus bad, right? That seems kind of useful. And complicating this is that you may have simultaneous access by the legitimate user and the bad person. And we don't want to simply be binary and block everybody or permit everybody. We need to be a little more clever than that. So we do this by really learning about individual user behavior. Passwords have been for the longest time the way you authenticate people, but it's sort of, we're going to sort of a post-password world where passwords are really not a very effective mechanism at all anymore. What we look at really is behavior, right? And on a per individual basis, we look at the history of the user as they navigate your site and as they use your product to understand over a long period of time what are normal navigation patterns for that user and your users in general. That may be about how they navigate the site, the IPs they came from, the times of day they use them, which sort of OS the person prefers, et cetera, et cetera. What we find is that, you know, we use a combination of this anomaly detection and heuristics, right? So a lot of this is detecting abnormal patterns, but some of it also detecting patterns we know to indicate malicious behavior. So when a bad actor comes along, it is usually pretty obvious from the way that they're navigating the site and some other attributes of that user's session that they are not the normal user that you expect. So this all sounds great, right? But let's sort of look at what this really means in practice. So there's a couple simple integration steps we want people to go through to maximize the data that we need to make good decisions around users and also to learn from those decisions. So a quick little demo here. Assuming that you've gone through the sign up, I'm not going to make you do the basic sign up for Castle flow. Really the part that matters is we give you this little JavaScript snippet pre-populated with your app ID. And what you do is you put that into your front-end code, your JavaScript code. Really on every page ideally, so you put it somewhere in the header normally. And what this helps us do is identify the particular user's devices that are associated with a given user over time and understand all the metadata we need to make good decisions about that user. So, okay, that seems pretty simple. What's this mean from the user standpoint, right? So we have a little fake app here. And the user would come in, log in for the first time. And, you know, from the user's perspective, we want to be invisible, basically. We never want the user to know we exist in most cases. Even in cases where something's abnormal, we encourage the company, whoever has the relationship with the user, to actually handle all the communication with the user and use whatever mechanism we normally use to reach out to users. So within Castle, what you see is, you know, you see that, hey, this person tried to log in, and they actually succeeded. And you can see some metadata about where they came from. You can see over time the history of their sessions as they've interacted with your product. You can click in and see, for example, a given session's metadata, right? The device that came from, location. We actually capture a lot more stuff than is seen here, but this is sort of the highlights that people tend to care about. And over time, you can see the session as they evolve and as the user interacts with your product. Now, that's part of it. The other part is a back-end integration. We actually also need authoritative information from your back-end in order to validate what we're getting from the front end, because the front end obviously is quite spoofable. And also to tell us things we can't get from the front end, such as authentication attempts, requests, failures, challenges, etc. So that is also pretty simple. In the case of a simple node-based application, you can just have a callback, right? So you include our library, and then you just put in a callback in the event of this authentication attempt to track the result of the user that tried to log in. And so, for example, we use this, if we would get this from your backend, but we get no corresponding front-end events whatsoever, that would be suspicious, right? That would be a signal we'd use to say, hey, this is not normal user behavior. So from the user's perspective, what happens? Let's talk about a more interesting user scenario in this case, right? So say now I'm going to try to be the bad person in this scenario, right? And since apparently most of the really bad hackers are in Sweden these days, we're going to simulate that scenario. So say I'm an attacker and I'm now in Firefox instead of Chrome, and I'm connecting from Sweden instead of San Francisco. And I'm going to do exactly the same thing I did before. From the user perspective right now, there's basically no difference. They go through, they authenticate, and everything seems fine. But what you can see on our end is something quite different. You can see the two sessions here that we recorded. You can see two very different geographical locations, and a difference in the user agents, obviously. And then what that triggers for us is a fast travel signal, right? It says it is not practical to travel from San Francisco to New York in the space of 5 minutes. So something abnormal is happening. Abnormal doesn't necessarily mean it's compromised, but it means it's not typical for what we would expect for this scenario. So, okay, that's great, right? That might be worth looking into if you're on the risk management team, but then again, you probably have millions of users and you're getting a lot of signals all the time. So a big part of our system is to actually be a full closed loop solution. So we empower the company, the customer, to make decisions based upon the information, the signals we provide them, and take a set of actions in response to the risk level that we are basically providing. So you can do, for example, you can permit access, right? You can just monitor and take no action. You may, for what we call the unusual level, which is sort of the lowest risk level, simply verify, right? So you can set a notification to the user out of band saying, hey, we noticed this attempt to log in from so-and-so, is this you? And based upon that, you can take action to reset the user's account or just permit. And we, in turn, then learn from that as well, right? So we get the notification event, and we know then, oh, that is normal for this user to be connecting both from San Francisco and Sweden because they have a VPN there, and that's all legitimate. You can challenge the users. You can do an inline challenge to verify whether or not this user is who they claim to be. And that obviously blocks the user's progress until they've succeeded, and we learn from that interaction. And you may, in the case of what we call a malicious, where we have very, very high probability that is being a takeover, you can just block that entirely and then trigger a user password reset. So what does that mean from a UI, API standpoint? It means actually very minimal changes, right? So what we do is instead of just merely tracking the event, we actually call our authentication endpoint, and we ask for a score at that time. And you normally do this right after somebody tries to authenticate. And you look at the response code and you say, hey, you know, if I get a recommendation to challenge this user, that's what I'm going to do. And otherwise, if that's not the case, I can just continue and the user is not impacted in any way. And most of our users never see this, honestly. Most of them are just kind of log in and log out and do what they normally do and are not aware that Castle ever really exists. So what does that mean from the user standpoint? It's sort of what you expect, right? The exact same scenario, exact same VPN, hitting the same endpoint, but now, because we've implemented the challenge inline, what the user sees is an inline challenge. So after logging in, or in the attempt of logging in, they get challenged to put in authentication code. In this case, the user is actually legitimate. They are actually going through Sweden for some reason. And so they verify the code, and they proceed. So that's kind of cool. What happens next? Well, say the user then again logs in again from the same scenario, but with a fresh session, so we don't have all the cookies and stuff we had before. But we still have already the event we consume, knowing that this user and this device are permitted to access from both locations. And so this time there's no challenge, because we learned that this device it's normal for them to connect from Sweden, and the user is not affected. So how we learn, right? Because the whole point is to improve. So we learn from customer events, right? So we learn from just the monitoring of the user behavior, profiling user behavior, and applying our heuristics and anomaly detection over time. We learn from user feedback. So when the user gets challenged or notified, we take the results of that and we apply it to our model to then not repeat that experience to the user if the access is legitimate. And there's the ability within our dashboard for the customer to flag certain devices, right? Certain risks as either being acceptable or compromised, right? So we also learn from those inputs from the customer directly, if they've interacted with customer support, for example, whether that's legitimate. And what that means is that there should be minimal burden for users. The vast majority of users never interact with anything that we do and are oblivious to the fact that we exist, and this is a benefit. But when an attack happens, we can actually be mitigating that real time, right? So what does this mean to most people? It means sort of, oh, this probably happens occasionally, and this is kind of a nice to have. We've actually implemented for customers who are significant, and what they find is when they're under attack, which is not all the time, but when they're under considered attack, they find somewhere in the order of 5 to 10% of the users being compromised. And many started with like, oh, send us a list, and we sent them a list, and we sent them a list every hour for hours and hours. Eventually, like, no, we don't want any more lists. We want to just make this go away real time when it's happening, right? And so our goal is to actually provide a full life cycle that makes this problem go away, in the sense that the mitigation to these compromises can be automated, and your customer support teams and risk teams don't have to be involved, other than being aware that it's happening. So that's Castle in a nutshell. Come talk to us. We have a booth. You can tweet at us. You can reach out to me directly, and happy to chat after.